Hi, my name is Lev Nelly. I'm president of Pumping Machinery, and with me is Jim and Joe from NRG Energy. And today, for a couple of minutes, we'll talk about the Pump Reliability and Energy Monitoring System, known as PREMS version 2A. In general, what it is we want to monitor pump performance, head capacity, power, and efficiency online live. We want to also measure its reliability, vibrations, and temperatures, also live. We want to be able to record it, send it to satellite or to the cell tower, capture that on the website, download it anywhere in the world, so the plant operations or engineering or management can watch it and remote evacuation live as the pump changes performance from point to point. So for the power plants, we happen to have today a pump school training in Atlanta, and during this training, we use this module. The guys for power plant just looking at the system the first time too, so it kind of unaudited general feedback sessions, feedback opinions on first sense of what the system does. So here we have a pump. Actually, we have two pumps. Imagine this is not a small fraction pump. Imagine it's your pump, 2,000 horsepower at a power plant or waste treatment plant or chemical plant or water waste treatment facility. The pumps, we need to capture the flow. We have a flow meter here. In fact, we have two. This is what's called the plant flow meter to the magmeter or venturi or anything that gets in the flow and send the signal to these wires. And I'm sure they're kind of not arranged very nicely. This is just kind of general idea of the concept. So the signal from the flow meter goes to a module we'll call the chassis. And then at pressures or pressure transducers on a discharge and the structure of the pump is also sent to the box. Vibrations. Here's a vibration picked up very easily installed. One on the pump, one on the frame, and there's option to put many more on several pumps. Temperature is red. Magnetic probe is a temperature sensor. We're measuring frame temperature and the pump actually water temperature in this case. Vibrations, temperatures, pressures, and flow. And the machine, the unit chassis here, translates all that information into head capacity curve, HQ curve, power curve, efficiency, and uploads it to a system through the booster wireless gateway, extending all the way to 5,000 feet. So the pump can be here, the local module can be 100 feet away, the booster can be somewhere on the roof without actually going to an internal plant system. It can be connected to a stator wirelessly or to a local protocol. It has a lot of flexibility and options. So when that system is going to the cell tower, it comes back here, and locally, imagine now you are at the office or a computer. You're looking at the computer screen here, which shows head capacity, efficiency, and power curve as is, and all these dots here is at points during the operation. If I turn the valve, Jim, if you can circle the valve a little bit on the discharge side. Let's say operations want to have less flow, so the flow will change. That flow now gets picked up, and the pressure flow at amps, by the way, I didn't mention the amps, the power also gets measured, the red clamp wire shown there. So we can see that here, performance live, and then the difference between the horsepower as is versus horsepower that it should be is shown as an energy loss per year in dollars. The input for that is kilowatt hours cost, the percentage of pump on an average runs a year, and based on this calculation and the data, it produces this curve comparing to the standard curve. You can also click on a summary sheet, and on summary sheet is showing the data as it is. You can also click on a time data. For example, I click on time data. I want to click temperature on the pump and temperature on the frame, and you can see how instantaneously the temperature is refreshed and show the trend of the temperature. If I want to see the power, I can also measure the power, and here's a power curve shown. The power, efficiency, vibrations, FFT, spectral analysis vibrations, I can see the first frequency at 55 hertz, the second and third. I can also look at tabular data and download it to Excel spreadsheet and analyze the data. You do it online, live, every 2 seconds, taking data. So as I said, this is kind of during the pump class, a little bit audited, and we want to have the guys kind of turn out what do they think about system. What is the pros and cons? What any quirky questions and points? What do you think, Jim and Joe?
Seems interesting. How easy is it to hook up at your plant?
What you do is you take all these probes. Let's say this is your pump. Mag base here, mag base here. For a pressure producer, you have to provide the tap. Then the pressure producer itself just gets threaded in. The wires, the box comes in here, enclosed. You open the box, you take the wires, you connect the wires to the pressure producer, the flow producer, drag the wire 100 feet or whatever through this box and look it out. I would say probably within 2 hours, you can have the system on. As soon as you have wires hooked up and turn it on and start on your computer, you're up and running. It takes 2 hours. Tomorrow you want to change, put another pump, you take the box, move it to another pump, hook it out, and you get running as long as the wires reach to that pump. Or you can add more wire.
So 1 or 2 pumps at a time.
Usually 1 or 2 pumps at a time, but this system right now, you can see multiple channels. We're only using now 1, 2, 3, 4, 5, say 8 channels. Overall, we have in this case 16, 32, 38 channels. We only use 8 over 36. So you can, for example, measure vibration on the motor inboard and a pump outboard, or you can do vibration on one pump, and a second channel could be on another pump, or compressor. You can mix and match data as long as you can label them.
So in addition to just knowing what your temperature is, your pressure and flows, and you know how you have to perform it.
Exactly. If your pump is supposed to be 75% efficiency, you measure it right now, it shows 68% efficiency. So that difference in 7% efficiency translates into dollars, and it'll tell you at this cost and this percent operation, that costs you $174,000 a year. Well, the next thing is, what do you do about it? Well, if the reason for the deficiency is because rings went out, or pump is not running in the right flow, you can analyze all this, and it lets its wearings. You want to pull apart and change the wearings to restore efficiency, that could be $50,000 job. So if you know you're wasting $150,000, $50,000 investment to repair a proper restoration ring makes sense. But if you know you're wasting $10, you need $50,000 to restore it, it's not worth it. So that could be a good tool to really, with that data in hand, to help make the decision. Do I do this pump repair, upgrade, or delay that?
So it makes a cost-benefit analysis very easy to simple.
It essentially makes cost-benefit analysis, and if you integrate it with a SCADA system, with your SCADA, PI, whatever system they call, then upgrades can actually see it live as well. And that is for upgrade, it's not necessarily from efficiency energy standpoint. Upgrade will be, he wants to know what's the bearing temperature, what's vibration. Many times at the plant, especially the livestock, they already have vibration monitors. Those are usually not for training necessarily, but to cut the pump off. The motor off if it goes to a problematic point. But it's not necessarily showing the trend. You can have vibrations 1.1 inches per second today, and a 0.15 for the next 2 months, and 0.17 2 months later, and as vibration trend comes out, you can make a decision to do something about before it's shut down and tripped in high vibration, at which point you can catastrophic failure. So it's not the substitute for already pluses and minuses checks on existing protection for your equipment, and many times some of the pumps or centrifuges just might not have this instrumentation. People, when they install it, might not consider energy high enough or critical enough to supplement this with vibration monitors and energy monitors. You may have a pump somewhere in the back of your plant that is not as critical, but you still might be interested to see how efficient it is. You can take the system, move it to it, hook it up, and you got it.
How long does that system store data for? How long can you train it back?
Typically, as a default, it goes for a year. But as you can see here on the screen, you can click, you can get 1 hour, you can get it 1 day, you can get it 1 week, you can get it 3 months, and then you go to the year, you can go even longer. But usually 1 year, all people want, then they can back up the data, And if you want to say what happens 3 years from now, you can retrieve that data as well. But typically, people take the data constantly, every couple of seconds. Why? But they might want to display it not every 2 seconds, but maybe every minute or 2.
You can change the interval.
You can change the interval. For example, my little study right now, when the shoe is going over the pump, somebody will be opening and closing the valve. I want to measure it every 2 seconds and display it every 2 seconds. Or if I want to know general training, I can still take it every 2 seconds, but display it every minute or every 10 minutes. But also make a program does it. Display it if there's alarm. If the vibrations went up, immediately point this thing and display it, not on store. So the flexibility is built in to fine-tune the system for a specific need of the plant or group of pumps.
Sounds like a pretty powerful.
Yeah, we look forward, kind of excited to have this. I like it. I use it for my pump school training, but the real thing is to install it in places and try it out and get some feedback. So thank you for your feedback, guys. And thank you, Andy, and our filmer. Can I say your name?
Ryan.
Ryan, also from RG, is filming. He was too shy to be part of the group. He wanted to film us, but Ryan is behind the driver and driving wheel. Thank you very much. Now, to get a hold of us, I'm Levin with Pumping Machinery. DrPump, they call me. My website is pumpingmachinery.com, or my email is drpump@pumpingmachinery.com, or 770-310-0866. You'll find me on the web. Look forward to help you. In the meantime, keep on pumping. Well, the video that you just saw illustrating the PREMS 2A system in action. PREMS 2A, of course, stands for Pump Reliability and Energy Monitoring System, Release 2A. In the demonstration, it is attached to a relatively small pump, obviously low efficiency, low head, low flow, but it is used for demonstration purposes. It can obviously be applied to any pump of any power in any configuration, whether it's a vertical turbine pump at a municipal plant, or boiler pump at a power plant, split case pump at a paper mill, chemical plant, you name it. The installation essentially will be very similar and quite straightforward and simple. Well, let's go through system description and the basics of how it operates. Well, you see the box that is monitoring a multi-channel system, including power, the pressures, temperatures, vibrations, and the stream when the system is energized and attached to the with the wires coming from a probes attached to the system then transmits the signal to the cell tower from where it is connected to the website, and you can get information about your pump live, online, any place in the world, any time of the day, 24/7. You, as a manager or engineer or maintenance manager, operator, have access to the system directly, either through your SCADA system or directly online, as we'll just show in the following couple of slides. So let's see what the screen, how the screen looks like, or several screens of the PREMS 2A system. Well, basically, the most common variables plotted on the screen is head capacity curve. This is the blue line. HQ curve, horizontal axis is flow. Of course, it's very small flow, 2 gallons a minute or so for the little demo unit. Flow on the horizontal axis, and then vertical axis is head, power, efficiency, energy, efficiency of the pump, as well as energy that is utilized by the system. So if we would download the data, the past data, whether it's 1 day, 1 week, 1 month, 3 months, or custom data with a Zoom capabilities. Let's try to go 3 months back. The data is downloaded, and from then on, it resides on the computer. So let's see what we're looking at here. Well, the solid lines is a performance curve, a manufacturer performance curve that is expected for the pump to operate to? Well, the real data, the multiplicity of data, is taken every 2 seconds, and it's also settable. It's not taken 2 seconds, but displays it it can display it every 2 seconds, or every minute, or every 10 minutes, depending on how close the trend and then user, you might be interested to show. So we have, in this example, the blue dots, the multiplicity of dots, shows various places of the palm hand for this operation in the last 3 months, in this example. The most noticeable are a main clutter of points somewhere here, which shows low head, and then if you analyze the red line, which is a horsepower line, the real data, the cluster of the data, is at a higher horsepower than predicted. Together, a higher power and a lower head produce low efficiency in comparison to what efficiency is expected to be. Then something perhaps happened later on, and perhaps pumps were modified or changed. The head is improved. As you can see, the head cloud moved up closer. Perhaps there was a wrong impeller or something else wrong with the pump or the system. So the head is recovered and now operates in pretty good close correlation to the expected curve. Efficiency recovered slightly, efficiency went up, but not still exactly right on the efficiency curve, indicating that the power is still somewhat high. Well, this is the data for the wide range of, for the long time, 3 months in this case. Let's see if we can zoom into a custom. And let's pick the date. We click on the date, and it's 2015. Let's go from January, say 14th at say 3 p.m. until today, the 18th of January. If we download the data for that range only, you'll see just a relatively few points. And again, head is low, power is high, efficiency is low. Well, there's also a function, energy waste. Over here, if I click on energy waste, it will show the data, well, in this example, $20 a year. So the pump is running in a way that deficiency between actual efficiency and projected efficiency translates to $20 wasted a year. It's a very small pump, obviously, the number is small, but it could be $20,000 or $2 million, depending on the size of the pump. Well, how does this data get calculated? Part of the input to the program is utilization of the pump 7 days a week, 365 days a year, or 20% of time, 30% of time. Energy cost, 10 cents per kilowatt hour, or whatever other cost your particular plant might be incurring. Based on the data, we calculate actual energy live at the point of operation wasted as a deficiency, so to speak, of the pump. Well, on the lower left side of the screen, there's also a power meter that reflects the same data, just in a different presentation. Well, that's one of the screens. That's a screen for performance data. Again, this is the data going way back to 3 months. And of course, if we study at the higher flows, we can find similar energy wasted, or greater in this case, or smaller, depending on pump operates or whatever happened to the pump and what the history of operation might show. Well, let's look at the other screens. Let's look at a summary screen. Well, the summary screen basically shows your project. Let's say in this case it's power plant unit A. And on the right-hand side of the screen are current data for the as it was taken at the last measurements. Current, high pressure, low pressure, let's say discharge and suction pressure, flow, temperatures, power, head efficiency, energy, overall vibrations, and spectral vibrations. Several peaks has come from FFT, fast Fourier transform, for the spectral analysis on vibrations. That's a summary screen. If we look at the time data, the time data screen shows the variables. Let's pick high side pressure and a low side pressure and display them on the screen. Well, we see that the pressure went from very high to very, very low and then became very highly negative, which indicates perhaps the probe was disconnected, artificially showing the error inappropriate. So we see that too. If we look at the frame temperature, here's a pump temperature, or let's try pump temperature and a frame temperature. We'll see the trend. The pump started, the temperature increased, and then several times the temperature was dropping down, indicating perhaps pump not running for some time. Now what happens to the energy wasted? Energy, variable, of course also reflects the operation of the pump. Vibrations, overall vibrations kept changing for quite high, over 1.2 inch per second, and then to nothing, meaning the pump perhaps wasn't running during this time, and then vibration continues this trend. So all the variables very easily can be plotted and downloaded to a spreadsheet or seen on your skater or directly on the screen. If you want to get details on vibrations FFT, let's say we click what happens in January 14th at 3:30 p.m. Here's the first peak at about 50, almost 55 hertz, which is probably roughly 3,600, 3,500 RPM. The last vibration was 0.128. The second peak, and then multiple harmonics are shown on the screen. If I scroll it down and click somewhere else, well, we can see that our spectrals change, and it's all presented dynamically on live as it runs. Tabular data, if I click tabular data, same data that can be done for analysis: current, power, high pressure, low pressure, flow, temperatures, pump head, overall vibrations, peaks. The typical data that normally would be used for analysis of a pump operation is plotted as well. System log will show us any problems with the system, and then going back to performance data, any issues, perhaps excess vibrations exceeding maximum or warning levels, will likewise be depicted at the system log. So that is basically the flexibility and strengths of the system. That is continuous monitoring and predictability of the vibrations, which is reliability related, temperatures, power, performance curve for the system online. So for more on that, please contact us at the website number is the website is shown on the summary page. Here's a phone number and the email and the website. I look forward to hear from you. And any questions, please let us know. Until we meet again for the next release of the updates on the PREMS 2A monitor, keep on pumping.